on reactive programming. What is RxJS? Which also two very, very hot topics today in the community and things that we're anxious to hear about and apply to our work. A few things just to go over. Just a reminder that this is a community effort, and we run off of the contributions of the community. So if you want to contribute an idea for a talk, if you want to speak on an idea of your own, if you want to speak on an idea someone else submitted, the place to do it is on GitHub. We have a repository, we have an issue tracker, and we just submit issues for all of our different ideas. So please go and find us, AngularJS Utah on GitHub, and submit a talk, and we'd love to get you on the schedule. Also, if you're interested in volunteering, again, community effort. If you're interested in volunteering, please, come talk to me. I would say talk to Jason, but he's not here this time. Talk to us, and we'd be happy to put you to work. And just so you know that I have some ideas and things that we're going to do to try to engage you guys a little bit better as volunteers. And that actually kind of relates to my next thing, which last time we plugged this survey we were doing. I don't know if you guys remember that, but it was a survey we were conducting that wasn't even just targeted at our meetup, but it was targeted at all the meetups in the area. Just general JavaScript Utah meetups. And we're trying to figure out how can we serve the community better? What are we doing well? What are we not doing well? And that was the goal that we had. So we have now the results of that survey, and I did a write-up on Medium. So if you guys want to go see that, if you follow AngularJS Utah on Twitter, it retweeted this post out there. Or you can find it on Medium, because I only have like one post on Medium, so it'd be really easy to find. But one of the things about the results of this survey, one of the things that we learned was that apparently, like, a lot of you want to volunteer and get involved, and more than I expected. And that's great news. So look forward to us. I have some ideas and some things that we're going to do to start rolling out more opportunities for everybody to get involved and volunteer. So again, if you're interested, come talk to me. I'd love to talk with you about that. So we're not doing that right now. So based on that, I think that we don't have anything. Oh no, right. One other thing. We also want to make sure that we thank our sponsors. Whew, that was close. Almost forgot that. Definitely want to thank our sponsors, Adobe, for sponsoring this wonderful space that we have and setting up the tables for us and getting the place laid out. It's a significant contribution that we really appreciate. Also, big thanks to Workfront for sponsoring the food and all the other odds and ends that we need to keep this meetup functioning. They're doing great. I do also work for Workfront, so I'm going to give you a bit of a brief plug. We are hiring for front-end developers right now. If that's something that you think you might be interested in, Workfront's a great place to work. Come talk to me. I'd be happy to talk to you. So with that said, I think that we can dive in. And up first, we got Julia. Julia, you ready to go? Okay, let's give it up for Julia.
Hello? Okay, thanks. Oops. Sorry, I think my slides got away. Okay, cool. Hello. That is me, and I'm going to talk about why changing things can be bad today. So persistent data structure which just means that always returns a new value when the old ones is getting modified. Therefore, the data structures are immutable. And that's all immutable data is. So on the top, we can see we assigned 10 to A, and then later we changed A to 10 times 2, which then changed A. And on the bottom, we have A is 10, and then we assign a new variable. Whenever we change A to B, then A is being, or A is not being changed. Or even better, if we use const variables, and we'll talk more about that later. So on the top, it's the same thing. We assign 10 to A, and then we change A, but on the bottom, we assign 10 to a const variable A, and then we assign the new value to a const variable B. So at this point, I guess some of you may say, I don't even care about this. So let's talk about why you should be caring about changing data. So sometimes so changeable is a global variable. And then in the bat function, we pass in a number and then another function. We then change this global variable by times that by 2, and then returns the function call of the pass-in function, right? So the first time we call this function, we pass in 1 and then multiply, which just multiplies the n to whatever changeable you pass it in later. So then the first time we pass that, the result is 2. And then the second time with the same input, we get different results because changeable is being changed internally. So that's not super bad. But what if we have an unknown function that we give the changeable value to? Then we just have no idea what the value is. And whenever I say unknown, I don't mean like you just call a random function somewhere that you don't even know what it is. What I mean is you may know what it is, but somebody else may have changed it. So then the results can be completely different than what you thought it was. So here we call the bat function again. We give it same inputs, 1, and then multiply. Then first time it returns 16 because of this unknown function changed this changeable variable. But then the second time it just completely blows. It just returns a random number that we don't even know why. So imagine when you go to the ATM machine, you get random things out. But you don't want that. Whenever you go there, you have some expectation of what you get out of instead of a random output, right? And that brings us another subset, which is stateless and pure function. Pure functions just means whenever you give a function same inputs, it always returns the same output. Every single time the function is being called, and it needs to, and regardless of outside changes. So whatever you do outside of this function, it doesn't matter. It won't affect the outcome of this function. So why do you need to care about that? So why are stateless functions important? Now we're going one level down. So stateless functions guarantees the result is always what you think it will be, which means there's no side effect. And then it also reduces the numbers of unit tests that you need, because whenever you test one single function, you kind of guarantees the results. So you don't need to test it every single time you test other functions. And then this produces fewer bugs, of course, because you get what you want. So let's come back to the immutable data structure. So this is a definition, and some of you may think, well, isn't that really expensive? Just because we're returning a new variable every single time there's a change to the data, right? And maybe it is fine when the variable is a string or a number, but it can get very slow if the variable as like a super nested object. And that is when the memory sharing comes in. So on the left-hand side, you have XS, which is, so XS hosts the original data, and it's a nested tree. So on the right-hand side, whenever you, on this diagram, you added a variable 8 onto the 6, and 6 is the parent node. And then 6 got copied over because that's a parent node. And then 6's parent node is 3, and then 1 also got copied over, but everything else stays the same. So then, which means a lot of the libraries or languages that implement immutable data also has the memory sharing thing that only changes the, so they only change the direct parent node of the changed object or node. And then this is another example. So on the initial tree, when you change the very, so the lower side 4 to an 8, the parent path H got copied over because that got changed. So did F and C. But then everything else stays the same. Did that make sense? But we were told at the very beginning that memory sharing is bad. But why? But why was it bad? Memory sharing is bad when the data can be changed, because then we kind of lost control of what the data is, and everything else that shares that memory can also got wacky. But if the data can be changed, then memory sharing is fine. So ClojureScript is one of the front-end languages that implements this kind of thing. So it is a dialect of Lisp, and it has immutable data structures, and it uses memory sharing. This is a simple example. So we define a vector v to contain 1, 2, 3 number, and then later we add 4 onto v, which returns 1, 2, 3, 4, but the original v was not changed. You don't need to worry about the syntax, it's just the Lisp syntax. And PureScript is another example. It's just implemented in Haskell, and it uses the same thing. And that's the example in PureScript. So we define an A as a list, 1, 2, 3, and then we insert into the position 1 of number 3 to A, but then when we check A, it's not changed, it's still 1, 2, 3, and we assigned the new thing to Y, so then Y contains the new variable. So that sounds awesome, but not everybody wants to change to ClojureScript or PureScript. So there are several libraries that you can use, and so I'm just going to talk about one is Immutable.js library. And that sounds promising, right? Because we're talking about immutable stuff. So this is a regular JavaScript, and when we so we have a regular map, that's just a map, and then we set this map to 1 and high, and then later we set it to 2 and by. The original map size got changed to 2. But if we use Immutable.js, we have the first map set it to 1 and high, and then when we set the first map the second time, we assign it to a new map. So then whenever we check the second map, the size is 2, but the first map stays the same. This is just another example of nested objects using it. So we have a nested thing that has a parent node of z, and then later, if we change the parent node z to 4, the nested map wasn't being changed. But if we assign it to another object, then the second object has only z and 4. And there's actually an Angular immutable that somebody created using Immutable.js that can be implemented in Angular. So, okay, so what if I don't want to use any additional libraries? Just because I may add on to size and stuff. And here are some of the ways that you can do to kind of prevent you from changing things. First is let and const. So let and const variables are both block scoped, so that means no more hoisting. And const values can actually or cannot be changed after you initialize it. But there are some exemptions that I will be talking about later too. So the let example. So on the top, we have a var example, which we assign 1 to A, and then later we change A to 2, even though we're still declaring A, the first A is being changed to 2 outside of the if loop, or if block. And then if we do it to let example, if we declare B, and then give it a 1, and then later we also declare another B to 2, the second B is actually inside of the if block. So then when we check it outside, the first B was still 1. So const example. So const variables actually cannot be changed once you assign value, and they have to be initialized. So on the top, we have const A equals to 1, and then later, if you do something like A equals to 2, it will give you an error. Same thing with the bottom part. So right here, we didn't give A anything, and that's not allowed. So remember I said const variables can be changed? That's not entirely accurate. Some can. So here we have a const foo equals this object, and then later we do foo.bar equals to 1. That is a valid statement. So everything inside of an object can actually be changed. And that's why you may want to use some libraries like Immutable.js or just change your language to be more safe. But if not, there's a slice or splice. So so we give A, B, C, D, E to XS, and then we want only the first 2 in the list. So then we use splice to get the first 2, but the original list is getting changed. Instead, if we use slice, same list, A, B, C, D, E, and then we use ys.slice to get the first 2 items on the list, then the original list was not being changed. This one, so on the increment function, we have this, so we're given person as an object, and then later we change this person's age, and then return the person back. Remember, if you use const, that's allowed. So then we return the person back, but then we have no way of checking whether that function worked or not, because by the time we check, the age is supposedly incremented. But instead, if we look at the middle function, we use object.assign, which basically copies everything in the person object to an empty object, and then change the age element inside of the new variable of person. So the original person object is now being changed. Or we can use the rest and spread. which it's the same thing. So we give it age and then whatever else you want to pass it into person, just in case it has like hundreds of things instead of person objects. So then you don't want to return every single one. You can return the age plus 1 and then the rest. And then this one seems pretty straightforward, but random numbers actually give you random results. So if you have a random number, I guess the best case is not to use it, but if you do have to use it, you just have to remember that you're using a random number, which results in different outputs, even if you give the same thing. So that may create problem that things used to work on Friday no longer work on Monday, kind of thing. And recursion. So we're all familiar with for and while loop, and for and while loop actually encourages mutation, where recursions encourages immutability. So here we have a for loop that we're just summing it up. We're just summing from 1 to n, right? So right here we give a result to 0, but then inside of the for loop we change result every single time we call it, and then we return it. So result is being changed. But if we use recursion, we call the sum function, so we're returning whatever n is plus a sum function call with n minus 1. So in this case, nothing's being changed, but we're still returning the correct result. Okay, so some of these concepts belongs to functional programming. So if you want to take a look into that, that would be great. And that's all. Thank you.
Anyone have any questions for Julia? Anyone? Ryan? Wait for me to come so we can get it on the recording.
So just one, you were talking about, so const, when you set an object to const in ES6, you can still modify the properties. You implied that in Immutable.js, you can't modify the properties. Is that correct?
Uh-huh.
And same with ClojureScript, you can't
ClojureScript and PureScript, yes.
And PureScript, you can't modify the properties of them.
Yeah, so they're more immutable in that way, I guess. Yeah.
Cool. Thank you.
Any other questions? Okay, all right. Oh, over here.
Okay, so my question is on what you might know about how many of the features that are planned for ES6 that might be cut. Do you know anything about that? Or if it's pretty likely that they'll all make it in?
I haven't heard anything about that, sorry.
Okay.
Any others?
So, Julie, how would you recommend that we go about taking these principles and using them with our Angular project? Is there anything specifically that we could do today to do in our own Angular projects?
Yeah, so I know, I think you can implement Immutable.js into Angular, and there is this, let's see if we can find it, the Angular Immutable library that I linked here, you find it. But I also know there's other libraries like Seamless Immutable by Richard Friedman, and those libraries are not specific to any framework, so you may be able to try it out instead of just using React or whatever. Those might be good.
So I have a question about, what you're really getting for going immutable here. Are you getting a lot of speed or better memory management or both?
Yeah, so actually I didn't put that on the slide. People have tested that using immutable data stuff, using memory sharing is actually speeding things up than not, because things like mutable structures, whenever I think even I think it was for Java, even when you read a variable, that costs more than reading an immutable variable. Like if you call it like get something in Java, then that may cost more than just using this. And so yeah, so one is speed, and two is just more safe, I would say.
Okay, so safety is a big deal. So are you using this in all of your code now, or just in some projects?
I did use Immutable.js in one of my projects at work, and it works pretty good. But I did use React, so yeah, let me know if it doesn't work that well with Angular. So.
Okay. All right, and are you suggesting that we would use it for all data structures? I mean, some of the examples were arrays or nested objects.
Yeah.
And then other ones were of just ints. Do you really have to worry about it if you're just changing the value of an int?
Right. So I think that depends from project to project, and that also depends on what kind of change you're doing and what, like why you're changing it in a sense, and what the safety cap is. By changing it, you may risk of other people changing it somewhere else, but if the variable is actually inside the function, that may be fine. So it depends, but yeah. So I guess it is, one is for safety, and two, you kind of reduced the possibility of you may change it somewhere else and somebody else may change it somewhere else that you may not know. Does that make sense?
So is there any way to do kind of a hybrid immutable object? So you had some attributes that are locked and some that are not?
Well, if you use constant let, that's kind of hybrid, because, I mean, let lets you change. It's just scoped differently than var, but const, you can also change it. And I know there is, well, I try not to change things whenever I can, but I know things get changed, and sometimes it's necessary, like if you get a date somewhere, then that's always changing. So again, it depends on what kind of solution you're looking for, if that makes sense.
Any other questions? Oh, over here. I think this will probably be our last one.
Kind of more of a comment.
Yeah.
Closure, or the design of using the functional programming language, kind of stresses this point of immutability. Out of Haskell, it's plain and pure immutable, period.
Yeah.
There are features in Closure that allow certain areas to be mutable, changeable, for the very reason that we're dealing with data that has to change.
Yeah.
But the primary reason for all of that was doing with parallel programming. It makes it very easy to allow different functions to go through different compute paths without mixing each other up.
Yeah.
And that's the reason for the immutability as being very, very important.
Yeah. Cool, thank you. Oh, one more thing. So if you use let and const, you kind of give an instruction to other of your coworkers that const variables, then they shouldn't touch it. And then I guess, so if you use const everywhere except one variable, then they know for sure that variable are meant to be changed. So it's also, yeah.
Awesome. I think that's it we have for questions right now. We gotta give Jeremy his time. But
yeah.
Were you saying something else?
Oh, well, this is my Twitter, and you can tweet at me if you have any other questions.
That's not your Twitter.
Oh wait, that could be my Twitter.
It could be. A cat is your Twitter. That's awesome. Okay. Thanks again, Julia.
Thank you.
All right, let's get Jeremy up on deck while he's getting set up. I just want to remind you, we got lots of food still. So if you're still hungry, that's your fault. Oh, goodness. I just killed everything by stepping on it. Brian, do you know what I just did? Okay.
I could do charade.
Well, was it Jeremy? Did it just happen to be the same time I stepped on a cord? Okay, all right. The other thing I'll just add real quick while Jeremy's getting ready about immutability. Immutability is one of the great things about it with Angular, specifically one of the problems that Angular 1 has been having is, at least in terms of speed, has been dirty checking. And immutability can greatly speed up what you need to do a dirty check for. And that's one of the things Angular 2 is going to be able to take advantage of really well. So understanding these things can help you have very performant Angular 2 applications. So, all right, so go ahead and get some food. It looks like Jeremy's almost ready. So,
Oh, here we go. Look at this. Do I need to?
yeah, you should be good. All right.
All right, sound check working okay. I was really looking forward to like describing my slides without the screen. It'd be kind of fun. Never done that before. All right. All right. So I think I'm good here. All right. Welcome. My name is Jeremy Lund. As Matt just mentioned, my topic is what is RxJS. I think it's really important that I think Julia's talk was a perfect lead into this because a lot of what we talk about with regards to RxJS is functional style programming and the value of immutability with regards to our variables and scopes. Got a lot to cover, a lot of different topics. If you want to follow me on Twitter, that's my Twitter handle. My GitHub address as well, that's a 0 between the Lund and the N. So anyway, let's get started. So there's 3 topics I'm going to talk about today. First one is what is RxJS? What is it trying to cover? What kind of things it's trying to accomplish? What is it good for? What's value? I mean, a lot of people are talking about it. The Angular 2 team's been talking about it. Jafar Hussein's been talking about it for 3 or 4 years now. You hear about it in React circles. Why on earth would I want to learn about this? And why would I specifically want to use it with Angular as well? So let's talk about the observable, which is the core part of RxJS that it's kind of its primitive. I was trying to think of the right word. It's the primitive of RxJS. Can everybody see my screen okay? The font the right size? We need it bigger? We're good? Okay. So everybody's probably written code similar to this here. Let me split this over. Let's get that out of the way for a minute. Just want to give you guys a browser view as well. Not that one. Where's my other browser? We're just going to escape out of this for a minute. There we go. Okay. So I'm going to get this up here, and let's make our console a little bigger. I thought the console would. Let's try this one more time. This was just working for me a minute ago. Getting the console larger. That's okay. All right. So I have a little demo here. We've written code like this before. Who's used the new, well, I guess new, it's been in there for a while, ES5 functional style constructs in JavaScript, like filter, map, reduce. You used those before? Yeah, pretty used to those. I like them a lot. They give us a good introduction to how we might use RxJS. So here's our list of numbers. They all have a value property. And all we want to do here is we have this result. If you've worked with those functions before, you've written code similar to this, where maybe you're mapping over the values. Map applies the function inside to each value in the list and then returns the result back into the list. It creates a new list between each item. And so here we are grabbing the value property off of each of these items, and then we are filtering them. The filter function returns true if the value matches the filter, or if you have it return true, it will include it in the resulting list. So here we're filtering out all the odd numbers and only returning even numbers. And then in order to consume that data and actually look at the list, we've added a for each to the end, and the for each is then logging out the values. If you can see my console, again, I was trying to make it bigger. Oh, you know what? I was pressing the wrong button. Oh, look at that. There we go. Why was I pressing Command 0? That makes it smaller again. That was brilliant. All right, so there's the values. You can see it's writing the values out to the console. Nothing too amazing here. We've probably written plenty of code like this before, or if you've used a library like underscore or Lodash, you've written something very similarly in that as well. Observables are a little bit different than that. So let's look at what's different with an observable. We've got some code conveniently pre-baked and commented out down here, so we're going to uncomment it and take a look at it. So let's save the code. Absolutely. I know that there's a better way to do this, but I'm just going to change it in here. Oh, come on, not the theme. Yeah, but then I got multiple files, so I gotta, let's put it in 200. How about 22? There we go. All right. Is that better? All right. Cool, thank you. So an observable is a little bit different. This is how we might do the same thing using an observable, which is the core to RxJS. Here we create a stream. Most of the time when you create an observable stream, which is the output that comes from an observable, you put a $sign at the end. Sometimes people use the name stream. I've kind of adopted the $sign. It's the syntax I generally like to represent a stream. And an observable is something that wants to be observed. So you have an observer that gets passed in, and then there's 3 operations that you can do on that observer coming in. You can do on next. You can think about that like an iterator, if you looked at that in other languages. Each item in the list, on next is the next value up on there. In this case, you can see that we're calling on next 6 times, 1 for each value coming through. And then observers, we'll talk about this, or observables have an onCompleted function you can call as well. You can tell it when the observable is done so it can be disposed of. And usually you return a function which is to dispose, do any cleanup logic that observable may need to do. So if we run this one, we've got and then to consume it. So that was the part to grab the data. We can then map an observable to another observable. So we just chain onto it. And this part is got to look almost identical to the previous code we looked at. We take our numbers observable, we're mapping, extracting the value property from each item in the stream, and then we are filtering all the odd values out. And finally, to consume it, it's a little bit different. Up here, we are using for each to iterate over that and grab the items to do side effects, to display it to the console log. In an observable, you need to subscribe to it. A key difference between observables and our regular arrays and lists is that it pushes values to you rather than pulling. Usually with an iterator style, when we do a for each, we're basically saying, grab each item out of the list and do something with it. With an observable, it's the other way. It says, I'm subscribing, I'm interested in what data you are going to provide to me, the stream of data, and then the observable has the opportunity to push you the data whenever it gets it. And you can think about how this may work with asynchronous programming, with things like events, with promises, with XML, HTTP requests. It allows you to do a lot of orchestration and coordinating of your code. But let's look at the results of this one, make sure my build's running. See these changes here. And I'm going to turn a library load on just so that, okay. Well, now that's almost too big. Let's make my console a little bit smaller. Okay, so we have 2 lists here. Before we had just the 2, 4, and 6. Now we have the 2, 4, and 6 and disposed. What it does is it calls the onNext all the way through, and when you call onCompleted, it disposes of that observable. And we just had it logging disposed when it goes through. So some people say with observables, oh, they're asynchronous because it's pushing the data, so it's really good for asynchronicity. You can see right here, this is synchronous code. You can use observables with synchronous code, and sometimes it's actually more advantageous than the regular lists, and here's the reason why. When you go through a list like this, our original array, remember the result of each of these operations is a new array. And sometimes, even though immutability is really valuable, sometimes it's expensive to create that list at each step. So sometimes when you're going through these arrays, you want to get the list as narrow as possible before you get to the end, because otherwise you're creating, you can imagine if this list had like 1,000 items or 10,000 items, I just created another copy of a 10,000 item list. I'm then filtering over that and creating a 5,000 item list. That can be kind of expensive. With the streams, it sends each value down the stream on its own, so you're not creating duplication like that. So we talked about pushing values. Another benefit of observables is that it can push or return multiple values through the onNext construct here. And yeah, so you get to return multiple values. You don't have to necessarily, with our other one, it's returning an entire list all at once. We're returning a value at a time, one at a time. Let's look at the laziness of it as well. What is an observable without a subscription? Well, let's see what it does. Let's just take this one little line out. It's going to reload over here. See, it does nothing. The cool thing about an observable as well is they're declarative. You set them up initially, and unless you have something subscribing to it, it doesn't do anything. That's great code. It's only going to do something unless once I'm ready to consume it and once I need it. The other thing here that I want to show is, let's put a little set timeout. So we can do asynchronicity around these. So let's add a little bit here. We got a set timeout block, and we'll just say, okay, around these last three values, we want them to be sent after a second. Now, it may not necessarily do what you expect. And it's definitely not doing what I expect. There we go. It only sent 2, and then it said disposed. Any ideas what's happening here? Why it's only sending 2 of the results? Well, it's this onCompleted state. When you go through the list, you can signal onCompleted at any time. So what it's doing is it sends those, and then it calls the onCompleted, and it disposes of that observable already. So what I can do is I can put this set timeout around the whole list. Now, after a second, it sends those additional values, and it also closes off the observable. So that's a really beneficial way to do this. We talked about this dispose function just briefly. Usually, observables return a dispose function so that it can clean up after the observable. We're not actually taking advantage of it right now. Let's do that. By the way, you'll notice I'm using const on every single one of my variables. When you have observables like this, it's declarative. There's nothing changing in there, so why not make it a constant? See, so I have my subscription, and let's do this. So what this subscription does is this gives me a handle to the subscription object, which has a dispose function on it. And I can call that anytime, and it'll just close off the subscription. So let's... so we had after a second, it's going to show those remaining values we had up here above. Let's just add a 500 millisecond timeout and say after 500 milliseconds, we want to dispose of our subscription. We're done with what we need. And this could be any other kind of condition. You can imagine you click on something and then you click something else and you want to dispose of it. That's one way to do it. So let's reload it. You can see after 2, again, it disposed. Why? Because the subscription was disposed before all the values were sent. If we set this to 1500 milliseconds, it's going to get the additional values and dispose because it's after. So those are some of the things you can do. You can push items. It's pushing rather than pulling. You can send multiple values. It's disposable. It actually will send, there's an on-error function too, so you can do error handling through these observable paths too, which is really, really valuable. One thing I wanted to mention, this is really noisy code. Imagine having to do onNext over and over again for your code. This is just creating a really basic observable. Really the equivalent to this is just down below. I can take that original, there's a variety of creation or factory functions that RxJS comes with to be able to adapt different data structures. One of them, I'm just taking that original numbers array that I had above, say let's just wrap it in a observable, and it's just going to return each of those items. It's going to call onNext on each item, and then call complete at the end. So let's switch our code out. And we see that it's working. The only thing it's not doing is it's not logging that dispose because that was in my custom observable. Okay, so that's observables in a nutshell. One of the things I do want to say about this is there are dozens of operators that you can use on observables to filter, transform, merge all these different streams together. We will look at a couple of them momentarily, but I want to talk about another subject because this is kind of a source of confusion with these observables and RxJS is like, why is it called reactive? There's this reactive part. I hear observable. What does that have to do with reactive programming or anything? So let's look at another example on that. So I've got an example called reactive. So we've got this function here. Let me pull up this other screen. We'll get reactive up here. So we have code like this, and this is very similar again to what Julia presented, where you have a value A and we have a function B. What if we want that function B there? It's just squaring A. What if we want that B to always be whatever A is times itself? It's very difficult to do when we're just talking about variables and simple setters and assignments. So we log out the initial A value, which is 5. We log out B, which is 25, A squared, simple math. We then change A to 10, and we log it out again. Well, we wouldn't expect anything differently than B still being 25. Why? Because we haven't applied a change to it at all. But we want to do something better. It wouldn't be nice if we could just actually say it's constraint, much like a spreadsheet. Its constraint is it's always A squared, no matter what A is. With observables, we can do that. So here I have an observable representation of a very similar thing. What we have, first of all, is just, again, this is one of the factories, this is of, where it just takes the arguments and puts them into an observable stream. Of 5 and 10, which is our two values of A. I'm delaying them just so we can see the change on it, and I'm doing this do on next. This is one of the operators. So delay holds values back, so that's one of the operators. The do on next allows you to tap into a stream and just log out something, which is really nice when you have a fairly long piece of logic to be able to tap in and kind of see what's going on in a particular area, or to apply a side effect. I then have my B stream. So my A stream was the stream of what A is over time. B is what B is over time, which is to take A and map over, squaring A together. We then subscribe to it so we can actually see it on the screen and apply it, and we see what B is when we have these. So with observables, it's going ahead and making that change there. And if we added another value, if we just added 11 and 13, etc., it'll go through each one of those and apply them in order through. So we can have some guarantees between streams that functions work together, values feed into each other. So that's kind of where the reactive part comes from. I know a bit of this can be overwhelming. In fact, a colleague of mine, one of the organizers, co-organizer, Jason Waters, sent out on his Twitter about a month ago. I asked him permission if I could use this tweet. He said, RxJS feels like using a chainsaw when a butter knife will do. And maybe that's how you might feel a little bit right now. There's a lot of different operators. Maybe you've looked at Introduction to RxJS blogs and felt a bit overwhelmed because you look at all the dozens of operators that they provide and all the different concepts. And it's so much different than how we normally do code, where we're applying variables and changing state in various places. Once you get used to it, though, I have a hard time using a butter knife at work. It doesn't work on a lot of the problems I'm trying to solve. So the RxJS team, in fact, responded to Jason, basically said, yeah, but it's a really cool chainsaw. So so I thought it was pretty cool. And it is. It's a learning curve. That's what I want to say here. So if you're feeling a little bit overwhelmed, I'm going to give you some resources here at the end that you can use to kind of get more familiar with this. I'm going to move this back. So I have a final demo here just in my stuff, and then we'll go over some Angular stuff. So my last demo here, what I have is basically a page where I want to show out some results. I have a JSON object that has names and it has avatar links to images, and I want to show them out on this page. So I said that this is really good for asynchronous logic. Well, one of the things that we can do, and when I've got this render results just as a convenience thing, but what we want to do is take the results and we want to put them in this result list that was on the in the browser window here. So what I'm going to do is we'll create just a real simple string. In fact, to save time, we're going to use the one I've got over here. Hooray for pre-baked code. Let's see here. I just don't think I can type it fast enough to get it, and I think you guys will still get the same point. So what we have here is you have a just factory, which just returns one value in the stream, and I've got this is the URL to the people service or REST API that has the data. And then we can take that value. I want to actually change this for a minute. We're going to change this to map. What I do is take that value, which is just the request URL, and then we have one of the other factory functions. We can return streams from streams. This one's taking an Axios GET request and turning it into a stream using the from promise thing. You can do this with Angular GET request, the $http.get, or in the newer one with Angular 2 has it as well. You can use other APIs that do promises. Anything that does a promise, you can transform into an observable. You just think of a promise being something that just returns one item eventually. Usually promises, they're not cancelable, which is the cool thing about observables, is you can cancel them pre-request, in the middle of request, and they provide all the other logic or benefit there. You can get them in as a stream. So we're going to put that in, and then let's just say search. We want to subscribe to that search, and we're going to just say, let's see, results, and we'll just call our render. That should do it. Render results, which is just right there. Let's see if that works. Hopefully that works. First, cannot read property for each of undefined. Oh, that was okay. So I did something wrong. I've got some pre-baked code here. If we need to revert more code, I can. In fact, I'm going to do that right now because I really want to show you the Angular demo as well, and afraid I'm not going to get to it otherwise. All right. All right. So this actually has my search in it too, so we'll show that. But what I do want to show you, what was I missing? Oh, yeah, missing something there. Okay. What I've got here is I've got a search that, let's just look at the latest code. So I have this search field up here. What I want to be able to do is type a name in and be able to get search results back, those names and those avatars that I was talking about previously. So I take the value that came from the search field. You can see from event here. Basically, you can take any element and you can say, okay, on the key up event or on the click event of a button or mouse over or whatever, you can take that and represent the values as a stream, which is really cool. You take the different events coming out and represent those as a stream of events. Take the value off of that input field, and then I want to create that promise, and my API has this name-like query thing where I can just pass that value in and get the results back in a text search. So I'm going to take that and I'm going to map that, and then I'm just subscribing to that search results and want to render them. So let's see how that works. So I'm going to reload this, and let's see, cannot read property. Oh, it's the same thing as I got before. That's brilliant. Okay, so let's see what's happening here in the console. I know what's happening. It's just not doing it the way I want it to do it. So, all right, let's do flat. Let's go back to what we had. Okay, all right. I won't worry about showing you that particular item. I wanted to show, the operator I'm showing is FlatMap latest, was basically, since you have a stream coming back from streams, it allows you to switch. You can't take a stream of streams and then try to get results out of it. So what it does is it'll basically cancel previous asynchronous requests it's made and just go with the latest one. You can imagine as you're changing a type ahead, the query value that you're sending in is going to be different, and so the results, you don't want them to get out of sync. Particularly if you think of a filter field like this, potentially, depending on the number of records that come back, it might actually be faster request as it goes on. If you're narrowing down a value, you're getting fewer requests back or fewer results back, it might actually be a faster request. So flat map latest just throws away the previous ones. It'll actually, with a promise, or with the asynchronous request, it'll abort it and move on to the next one. So that's really valuable. So we've got this, but we have two problems with this one right here. Number one, good, it shows all the values now, but when I did it initially, it didn't show anything. Let's fix that one first. One thing we can do here is there's a start with operator, which basically says prepend to the stream this value. We're just going to add a empty string. Oops, let's add two of them. Let's add one. So now when it reloads here, we've got all the values there. So those operators, it's nice to be able to do stuff like this declaratively and just see in the stream how I've got stuff arranged. The second thing we're going to do is we don't like how noisy this is. If you go back to the console and the network, let's see, if I just start typing A, B, C, it's doing a request on every single one of these. Every time I touch the keyboard, it's making a request. That's kind of noisy. Really, most of the time, if you're doing a name search, you may want to give them enough time to type a name. So all we do here is we want to add, you can do a debounce, and you can set some kind of millisecond limit. And basically all that does is say, don't actually pass the value on down the stream until a certain limit. So let's see what this does instead. I wish it didn't, let's see here. Let's take the XHRs instead. So if I go B, A, B, okay. So it waits a second there, let's see. I don't know any of the people's names in here, but I just typed PETT in really quick, and it didn't do one with every keystroke, which is definitely going to save on bandwidth. The other thing that you can do here, so if I just sit here and touch the keyboard, I'm just hitting the arrow key. It's sending requests because it registered a key up event. The other thing you can do with this then is you can add a distinct. I said you're going to want to know all these operators. So it's got them by categories. You can do distinct until changed and add that. Now it's not, I'm sitting here hitting the arrow key. It's not changing. If I do B, and I was like, oh, whoops, I didn't mean a B. I meant A, B, and I can switch it around, and it's only going to do requests when it means. So with some very simple operations, we can make great improvement here on how we do code. Just a couple more items here. Okay, so let's talk about Angular. What about Angular? We've got that on the horizon. We're at an AngularJS meetup. We should probably be talking a little bit about Angular. Well, number one, there are extensions out there to integrate RxJS with your Angular 1 code. That's supported by the official RxJS project. The Angular 2, you can use Angular 2 without RxJS, but there's one of the members of the core team, Rob Warmald, who pushes RxJS really hard. He's got a really, really nice integration in there, in their code. So just for a last demo here, if I can pull it up. I don't know, who's looked at Angular 2 code previously? Okay, so hopefully it's not too mysterious. Just believe me when I say this is a nice integration. So what we have here is we have a type ahead demo, just similar to what I just did. Type ahead seemed to be the preeminent example for RxJS because it requires a lot of coordination between UI events, asynchronous requests, and rendering stuff on the screen. So if I wanted to look for, there's the new Lego Batman movie trailer that's been out. If I wanted to look at this is a YouTube search, so I could do Lego Batman, and I can get some searches here. Need change, it's just a real simple type ahead search. This is the way it's done in Angular 2 code. So you import Rx, which is the reactive library. What you do is you set up on your component class a observable type on there. So you have a member variable of your class or one of your public variables that whatever you want to have as an observable, and you make it of a type observable. And then that value inside the class does this code look kind of familiar, look similar? This is a observable stream right here. So you can create observable streams inside your Angular code that represents very similar to what we just worked with. This is RxJS 5, where I've been showing you RxJS 4. RxJS 5 is just still kind of in beta right now, but very similar code to what we did on the other one. But it's like, where's the side effect? Where's the subscription? How do I render on this page? There's this one little thing right here, this pipe async. So we've used filters before in Angular. They call them pipes in Angular too, and they have an async pipe. And what that pipe does there in your list is, we're used to with NG4 or, or in the previous version, how it was done. We're used to putting filters on the end. But what this does is it says, let's take the async value. This is observable. I'm going to subscribe to it. And the results of that, I'm going to iterate over and render them in the page. So that's what that's doing there. It subscribes right in place. It's a really elegant solution for integrating observables into your code. Just in closing, let me give you a couple of resources because you're going to want to learn about this stuff. This is exciting. I think it makes our code a lot easier to maintain. It's more performant because you can keep track of where your changes are actually happening rather than a lot of observes and watches and things. Docs and resources, I will send these out on the Meetup. But basically, we have the official documentation. We have LearnRx, which is a tutorial that Jafar Hussain wrote where you can actually go through some of the stuff similar to what we've done here, go through, learn about the functional operators, and then learn how that applies to RxJS. RxMarbles.com is awesome. It's visual representations of what the operators do, so you can kind of visually see how they work together, what a merge does, what a scan does. There's this Introduction to Reactive Programming You've Been Missing by Andre Staltz. You'll definitely want the link. That's one you can't memorize. It's really long. Video resources. There's been a lot of video resources that have been coming up over the last several weeks. If you subscribe to Egghead, they've got a lot of resources on RxJS that have just shown up. Just look for RxJS. There's an introduction to RxJS that Andre Staltz just did. Jafar Hussain's got one on there. John Lindquist has got some stuff on there. Front-end Masters, this is Jafar Hussain again. I've taken the Front-end Masters course. It's brilliant. It's really in depth. And finally, as far as looking for videos, look, if you want people to follow to find out more information or look for the YouTube videos, Ben Lesh, Jafar Hussain, Mad Podwasaki. Again, those are my links, GitHub, Twitter. Send me an email. Thank you for your time. I'm happy to take them. I know I'm a little bit over, but I'll take questions.
Do we have any questions for Jeremy about RxJS? Yeah, Justin.
So I might be a little behind, but there was a proposed spec for what was ES7 for observables. How is this different than ES7 observables? Well, it's been renamed now, but
that's an excellent question. So the spec that was on the ES7, it's still out there. I can't remember if it's in stage 1. I think was submitted by Jafar Hussain. He's part of the TC39 committee. So it's one that he's been pushing for a few years. Netflix, they find great benefit and stuff like this. So he's still pushing it out there, but it didn't make it into what we call ES7 or ES 2016. So it's one and the same. The syntax might change a little bit over time, but the concept of an observable as a primitive is still the same.
Who else we got?
Ryan's got a.
So other than type heads and other search things, what are some common use cases for observables?
It's a great question. So a lot of it is for coordinating and synchronizing things together. You think about when we do a web application, a lot of times we're having somebody type into a form. A lot of times we're doing searches or clicks or other things. We have click events, we have inner events, we have asynchronous HTTP requests, XML HTTP requests, and then we have UI side effects that need to happen and coordinated. So you can use them on event handling in coordination. Drag and drops is another great example. You can just listen to mouse down events. You can listen to mouse moves until mouse up happens. And you can move something within there. You can write, like in 5 lines of code, you can write a drag and drop, which is really nice. But a lot of it is about coordination of all these asynchronous things. I want an animation to happen when I click this, and well, that's happening. I want something to load in the background, that I want something else to happen when that completes. There's a when you need to coordinate all these different things we're doing in the UI, RxJS, in my opinion, is a great solution for that.
Mind if I add one to that, Jeremy?
What's that?
Can I add to Ryan's question there?
Yeah.
Sure. So one of the things that I've noticed that I've liked, you think about when we look at Angular or React or really any of these templates, we have this nice declarative, composable way to render a UI. Observables give us a way to use composition and a declarative style with how we handle events coming from the server, coming from the user, coming to all sorts of things, whereas before we didn't really have a lot of the tools in place to be able to handle in that kind of composable, declarable style.
Right. And if you looked at my code, like I said, everything is a const, and I didn't have any intermediate variables between things. They were only at the function level in order to get stuff done, and that's a refreshing syntax. You're not worrying about where a variable is being mutated in other locations of your code or your application. So having a nice structured data flow. Other people use Redux for stuff like this. There's actually an NGRX, which is a store that Rob Warmwald wrote that is RxJS, but it's a Redux implementation on top of RxJS. Very simple implementation. So it's called NGRX store. And actually, if you go out to NG&L, the Netherlands Angular conference, they posted that on YouTube. If you look for Rob Warmwald out there, his talk talks about NGRX store.
Cool. What else we got? RxJS observables, good stuff. Can't be. That's it, really? Okay. Jeremy.
I was going to say they want to go or they want to get seconds. You can get seconds if you want. I don't mind people getting up and walking around.
So what's your adoption rate of RxJS at Workfront? Like, are you guys using it like heavy hardcore? Or are you like one of the front leaders trying to convince the rest of the team to get on board?
That's an excellent question. The answer to that question is I'm learning with the rest of you, number one, but it's something I want to adopt more. There's a number of widgets that we've had around for a long time, and I've been looking at different solutions. Like one of the widgets is a type ahead. And I look at that and I just lament, why can't I just convert this over, this code, this 1,000-line widget would be so much nicer. So our adoption rate right now, we're kind of vetting it right now and looking at where the right places are to integrate it, but we certainly haven't been pushing it yet. So, but I have a feeling because we're looking at Angular 2 in a number of places in our code base as well. We'll be looking at it a lot more seriously because we have a lot of the problems that RxJS solves.
Any others? Ryan.
For the record.
I was just going to repeat the question. Come on.
Yeah, that's right.
All right. Go ahead, Ryan.
You had a spot there where when you were showing the A, the B subscribed to A, and you were doing just square rooting, or what was it? A times A? Is that what it was?
Right.
You were squaring it. If you have a lot of those, I imagine it would slow down, just like if you have a lot of Angular washes. Do you have to be careful of that? Have you had experience with that?
I don't have a lot of experience with it. My understanding of it, and just through it, it's generally more performant because we're focused in specific data flows going through. So you think about like Angular 1, and I know that they've improved this with Angular 2 because data binding is a second-class citizen now in Angular 2. But in Angular 1, you think of all the watchers and digest has to do. Anytime something changes, like, oh, go check everything. This is like very focused. It's checking specifically, you think of like event broadcasting. It's only checking things that are interested in that. So when it changes, like, oh, I was interested in it. So I think you could go overboard if you've got, a lot of them, thousands of them or something. But generally speaking, that's usually a handful of things focused on that one change and then propagating through that way. So.
Well, and then on those, can you also debounce that? Can you debounce when B updates?
Mm-hmm.
So that if you did have something that you had a lot of subscriptions on or whatever they're called, you could debounce those. They would only take effect after a bunch of things that happened?
Yeah, there's several different operations to handle performances and back pressure. So there's buffers. I was showing Matt earlier a demo with the Konami code where you type keys in. It's doing key up, if you're familiar with the Konami code from the old Nintendo. And you put in the secret code, and it had a buffer of 10 characters. So it was keeping track of the last 10 characters. You can do buffering. There's sampling. There's throttling. There's debouncing. And you can use it, once it's an observable, it's a primitive, whether it came from a promise or from an event. And so you can use any of those operations on them. Your mileage may vary on them. Some of them may not be as applicable, but.
Awesome.
Yeah.
Thanks.
All right.
All right, we'll take one more. We got one more question. Or we could just wrap up, I guess. Okay, all right, I guess. All right, thank you, Jeremy, again.
All right, thanks.
So yeah, thank you to our speakers, Jeremy and Julia, both great talks, great topics. We're really glad to have you. Thanks again also to our sponsors, Adobe and Workfront for putting all this on. If you guys want to stick around and hang out for a while, like that's totally cool, and get to know each other a little bit, do some networking. I think that would be awesome. Get some more food, but otherwise we'll end it here. Thanks for coming.